variable K-map. In the earlier sessions, we have discussed how to construct a 2-variable K-map, 3-variable K-map, how a given switching equation can be reduced using the 3-variable or 2-variable K-maps. Also, we discussed what is an prime implicant, what is an essential prime implicant. Moving further, a 4-variable K-map. In a 4-variable K-map, the number of variables we will be having equal to 2 to the power of 4. So therefore, a K-map will have 16 cells. These 16 cells, when they are arranged in the row form and the column form, we will have 4 rows as well as 4 columns. So let me represent these 4 rows and 4 columns. This is a 4-variable K-map. The question arises now, how do these cells which can be placed with minterms or max terms, for which consider 4 variables. In our example, let me consider the 4 variables as A, B, C, D, in which A represents MSB, D represents LSB bit. Since there are 4 columns, the number of variables which are required to represent the 4 columns are 2 variables. So therefore, let me take the C and the D to represent the columns. So hence C will be writing for the columns or assigning for the columns. If the rows are considered, there are totally 4 rows. So therefore, 2 variables are required. Let me assign AB to the rows. The possible values for the rows and the adjacency, the redundancy removal, keeping in mind the codes are the variable values which are assigned in such a way that there is only 1 bit variation amongst the adjacent rows as well as amongst the adjacent columns. So hence 0, 0, 0, 1, 1, 1, 1, 0 for all the rows. Similarly, for the columns 0, 0, 0, 1, 1, 1, 1, 0, which will maintain the redundancy principle. When the each cell decimal value has been identified, 0, 0, 0, 0 represents cell 0. 0, 0, 0, 1 represents cell 1. Similarly, 0, 0, 1, 1 represents cell 3. 0, 0, 1, 0 represents cell 2. 0, 1, 0, 0 represents cell number 4. Next cell is 5, 6, 7. When the next cell is considered 1, 1, 0, 0. 8 plus 4, it is 12. So 1, 1, 0, 1, it is 13. 1, 1, 1, 1, it is 15. 1, 1, 1, 0, it is 14. When the last row is considered 1, 0, 0, it is 8. 1, 0, 0, 1, 9. Then 1, 0, 1, 1, it is 11. 1, 0, 1, 0, it is 10. So this is how all the cells will be identified in a 4 matrix K-map. With this K-map, let us solve few switching equations. Through the example 1, simplify the following 4 variable switching equation using KMAP. That is Karnaugh map. So the equation is as follows: A as equal to f of w comma x comma y comma z is a function of 4 variables, consists of the min terms 0, 1, 4, 5, 9, 11, 13 and 15. To simplify such switching equation, which is represented in the decimal notation, we have to first construct the K-map. So solution is as follows. Construct the 4 cells, or sorry, 16 cells K-map. And represent all the variables, MSB variables to the rows, LSB variables to the columns, or vice versa also you can make use, but during that time the cell value will change. But this is the regular notation in most of the books we will be referring. Hence the same notation I'll be following. WXYZ, okay. When it is considered, the 0th cell is having 1, first 1, again 4, 5, 1, 1, 9, 11, 1, 1, then 13, 15, 1, 1. If you look at here, this is 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. This is 0th cell, first cell, then 4th cell, 5th cell, 9th cell, 11th cell, 13th cell, and 15th cell. Now, after placing these midterms onto the K-map, grouping has to be done. During the grouping, we have to see how many adjacent maximum cells can be grouped. If you look at here, 0, 1, 4, 5 can be grouped. Yes, that is the one grouping we can make. The second grouping is 13, 15, 9, 11. So this is possible. And one more grouping it is possible is the column. So how many groupings it is possible? 1, 2, 3. From which, if the prime implicants are the essential prime implicants we are representing, group 1 depicts 0, 1, 4, 5. This is group number 1. Group number 9, 11, 13, 15. Group number 3 represents cell number 1, 5, 9, 13. If you look at here, the group number 1, once this 0 cell and 4th cell has been grouped to cell number 1 and 5. So hence this is an essential prime implicant. if the second group is considered in which 13 and 15 has been grouped only once. So therefore, this is also an essential prime implicant. Whereas group number 3 in which 1, 3 already has been combined with 0 and 4. Similarly, 13 and 9 has been combined with 11 and 13 cell. So hence this is a only prime implicant. Hence, if the final expression has been written, here in this case, y bar is common, 1 between 0, 1, 4, 5. Amongst the columns, y bar is common. Amongst the rows, w bar. So therefore, w bar, y bar. If the second group is considered, between rows, w is common. Between columns, z is common. And if the prime implicant, if it is considered, it is only y bar z. In the rows, none of the variable is common amongst all the rows. Hence, y bar z only column value have represented. The final result or final optimized redundancy removed equation, it is only the essential prime implicants. So therefore, K is equal to W bar, Y bar, odd with W z. So this is how using 4 variable K map, we can reduce any 4 variable switching equation by identifying the essential prime implicants as well as the prime implicants. Thank you.